Assalamualaikum. My name is Muhammad Rizman. Today I'm gonna present to you my research paper, a review of solar radio burst detection using CALLISTO. Solar radio burst is the natural phenomena which related to the solar flare event. There are a variety of spectrometer that captures the solar radio flux and present the detection on solar radio burst. One of the spectrometer is known as a compact astronomical low-cost low-frequency instrument for spectroscopy and transportable observatory, known as CALLISTO. There are 5 known types of the solar radio burst. This paper will review the finding made by CALLISTO in detecting the solar radio burst. So, this is basically our solar system look like. Sun is the center of our solar system, and each planet orbiting Sun in their own path and distance. As the single and ultimate energy source, behavior of the Sun affected entire planet, including Earth. So every activities that happen in the Sun, which is referred to the Sun's activities, directly affected the condition of all orbiting planet, and this effect defined as a space weather effect. Solar flare is one of the Sun's activities that contribute to the interference on Earth's magnetosphere. As seen in the figure, magnetosphere is one of the atmospheric layer of Earth, and it is the defense mechanism of Earth which protect Earth from greater damage done by the solar flare. So, why we must concern about the solar flare? The reason is that solar flare event can bring an effect on Earth without our concern. Solar flare event affected and condemned telecommunication network, satellite system, navigation system, international grid system and others. Solar radio burst is the indication and early sign of solar flare event. Solar radio burst is defined as a disruption in radio frequency spectrum and appear in a low frequency signal. So this paper will review the findings made by CALLISTO through its database, which is from eCallisto website, in observing and detecting the solar radio bursts from the data gained all over the world. CALLISTO receiver instrumentation able to detect solar radio bursts between the range of 45 to 870 MHz. It is used variety of antenna to capture the burst. As for Malaysia, low periodic type antenna is used and its coverage is shown in the figure. As shown in the slide, eCallisto can be accessed online with the worldwide database. It is constantly updated with the solar radio flux reading. With this feature, there is why Callisto have been utilized by researchers worldwide and one of the source for solar radio flux data. There are 5 known types of solar radio bursts, namely as Type 1, Type 2, Type 3, Type 4 and Type 5. Each type has its own characteristic, frequency range and its appearance duration. This classification is made to distinguish their pattern and to expect the incoming solar flare event. This type is not indicating their stages, thus the formation of the solar radio burst is basically based on the observation and its associated characteristic. Solar radio burst type 1 is shown in the figure, known as a narrow bandwidth burst because of the range of the frequency is between 80 to 200 MHz. It has active regions and flare-like structures, has an eruptive behavior, and only take 1 second for single burst, and during the storm it may take an hours or even days. Solar radio burst type 2, as shown in the figure, known as a slow frequency drift, as it takes 3 to 30 minutes to complete its burst. It usually appears in the second harmonic structure and has flash-like structure. The detection bandwidth is between 10 kHz to 1 GHz. Solar radio burst type 3, known as fast frequency drift. It occurs in single or groups bursts. It has active regions, has flash-like structure and usually associated with proton emission and magnetoshock wave. The detection bandwidth is between 20 to 150 MHz, and it may take an hours or even days to complete its burst. Solar radio burst type 4 has three categories, which is stationary, moving and flare continua. In stationary burst type 4, it is in broadband continuum with fine structure, flash and proton emission. The frequency range between 20 MHz to 2 GHz, and it may take hours to even days to complete its burst. As for moving burst type 4, it is in a broadband structure. It has a slow frequency drift, has smooth continuum, has eruptive prominences and a magnetoshock wave. The frequency range is between 20 to 400 MHz, and it may take 30 minutes up to 2 hours to complete the burst. For flare continua, it is again in broadband structure. It has a smooth continuum, flash and also proton emission. The frequency range is between 25 to 200 MHz, and it may take only 3 to 45 minutes to complete its burst. Solar radio burst type 5, as shown in the figure, is known as a fast frequency drift. It has a smooth and short continuum, has an active region, and has flash-like structure. The detection bandwidth is between 10 to 200 MHz, and it may take 1 to 3 minutes of its burst to be completed. As for the conclusions, the 5 types of solar radio burst detection is successfully carried out using CALLISTO, as the entire data obtained is from CALLISTO websites. So the understanding on the type of solar radio burst is compulsory in preparing the material and data to develop a prediction model. CALLISTO is the manifestation of collaborative work from all researchers over the world in preparing one big database of solar radio spectrometers. With that, I end up my presentation. Thank you.